Okay, in this video we are looking at calculating GPE and KE. So, sometimes in your GCSE you will be asked to calculate the amount of energy that has been transferred to either something's gravitational potential energy store or its kinetic energy store. And you will use these two equations to do so. Let's look at GPE first. Let's imagine I want to calculate the gravitational potential energy transferred to a pen which has a mass of 70 grams raised from 2 meters above the ground to 3 meters above the ground. Okay, let's get that equation up. We have GPE is equal to mass in kilograms times G, which is 10 for Earth, times change in height in meters. So for my pen, the mass was 70 grams, so that's 0.07 kilograms, times 10, multiplied by my height change. Well, it went from 2 meters to 3 meters, so that is a change of 1 meter. So that is an increase in gravitational potential energy of 0.7 joules. Okay? Now let's have a little look at kinetic energy. Calculate the kinetic energy of a car travelling on a motorway at a typical motorway speed. Okay, let's grab that equation first. Kinetic energy is equal to a half multiplied by mass in kilograms multiplied by v squared, which is my velocity squared. So for a car on a motorway, I need to estimate its mass, and that is going to be roughly 1,000, and I'm going to estimate its speed, and I'm going to say it's travelling at 30 meters per second. So we have a half times 1,000 times 30 squared gives me 450,000 joules of kinetic energy. Now, often we are going to use these two equations together. To think about why that's useful, I'm going to bring back my pen and I'm going to consider dropping it from a height. As I put my pen at a height, it has a lot of energy in its gravitational potential energy store. And if I let that pen fall, as it falls, it has less and less and less energy in that gravitational potential energy store. But energy needs to be conserved. So where does all of that initial gravitational potential energy go? Well, as it falls, my pen gets faster and faster and faster. So the gravitational potential energy that the pen is losing is being converted into the kinetic energy of my pen. And if I raise my pen to a higher initial height, giving it more initial gravitational potential energy, then it should have more kinetic energy at the bottom. So we can say that the gravitational potential energy lost by an object is equal to the kinetic energy gained by that object. Apart from the fact that some of that gravitational potential energy is usually converted to heat too. Let's have a look at an example of combining these two equations. We have a bird of mass 2 kilograms. It's hovering at a height of 350 meters and it falls down to 200 meters. What is the speed that it will be moving at the end of that fall? So my gravitational potential energy lost is going to be equal to m times g times the height that my bird has dropped. So that is mass 2 times g 10 times that change in height is 350 minus 200, which is 150. So there is a change or a loss of gravitational potential energy of 3,000 joules. That is equal to the bird's gain in kinetic energy. So for my kinetic energy, I have a half times mass times v squared. 3,000 equals a half times 2 times v squared. Therefore, v squared is 3,000 divided by a half times 2, and therefore v is equal to 54 meters per second. Okay, hope you found that useful. Please do like and subscribe. Download the notes for those worked examples, equations and units. Thanks for watching.